my questions for evens. It says the function is equal to log base 3 of x minus 1. So in my mind, what I want you to do is I want you to be at a point where you can picture the parent function. So the parent function is going to look like this. It's going to go through this point, which is 1, 0, and it has this basic shape with an asymptote here. Okay, so I want you to be able to picture that, and if you can, then the translations make sense. So what is the translation when it says x minus 1? Which way does it move? To the right or the left? To the right. So this moves right 1, which means that the asymptote's going to move right 1. It was at x equals 0, and now it's at x equals 1. So it moved right 1. That means the starting point that was at 1, 0 is now at 2, 0. So you can sketch it if you know that information really quickly. Because now we have here the asymptote, and the point got shifted as well, and this is my general shape of it. It follows the asymptote down, it goes up, it looks kind of like that. Then what do? You might want to check a point, or two. Well, let's check a point and see what we get. When I said making an XY chart has to be thoughtful, this is what I mean. If I plug in a value like 2 here, oh, not 2, 3, this is 1, 2, 3, that would give me 3 minus 1 is 2. Is 2 a good number to use for the base of 3? No, because what I'm looking for, I need this to be like either 1/3 or 3 or 9 or 27, something that has to do with 3 as a base. So what number can I plug in here that would give me 3 as a base? 4. 4 is great. 4 is a good choice. So we have to be thoughtful about the x values because you want it to be like 3 to a power. You're trying to get a power here. All right, so what does that mean? If we try 4, we're going to have log base 3 of 4 minus 1, which is log base 3 of 3. What exponent do you put on 3 to make it equal to 3? 1. So these have the same base, and so you're using this exponent here. It's like they cancel out. Logarithms are exponents. So the exponent is 1, and that gives me the point 1, 2, 3, 4, and this would be 1. And that gives me an idea of the sketch of it. So mine's a little bit tall, but that's okay. So I want you to be thinking about translations, but the translations only work if you know where you're starting, right? So if you have a general idea, then you can move things around. Let's look at these others. 29, 29. Okay, 29 has some interesting things happening. It has two things happening. First, my starting point is different. So I want to find out what makes this 0 and what my shift is. And to do that, let's rewrite it. Let's write it negative x plus 2. Does that change it at all? I just moved it. It didn't change anything. What if I do this? Now I factored out the negative, and it looks normal. So if I rewrote this as log base 3 of negative x minus 2, the translations become more obvious. This is a flip, and this is a negative 2, so a right shift of 2. How about that? Does that make sense? We're going to try really hard to stay awake, even though it's hot in here. So this is right 2. So my graph Yes? Oh, hello.
Times.
You're good.
Stacy, I got called regarding vaccine availability.
Okay.
Kinston,
Oh,
Walgreens.
perfect.
She just needs to know if you want to take it.
Okay,
So,
thank you.
thank you.
Okay, so we flipped it and we moved it right to, which means we need to consider what to put in my XY chart. So let's say, what could we do? If it moves right to, but it got flipped, then it would have started here. Usually they start right here. This one moved right to, and then flipped. So we have to consider what that is. So what do we do? This is very confusing. Tell me about what I did in the last problem. I thought about ways to make this into things of 3. What could x be? Can x be 1? 2 minus 1? Ooh, that actually works. Because log base 3 of 1, if we plug a 1 in here, 2 minus 1 is 1. What exponent can you give to anything and it gives you 1? So the output is 0 because anything, 3 to the 0 is 1. What else could we put here? How would we make it 3? 2, not minus 1, but how would you make it plus 1? What would x be to make it plus 1? We'd have to change the sign, right? So we'd have to say negative 1. What if we put negative 1 in? That works, right? 2 minus negative 1. So that'll be 3. We need the power of 1 there. So we're just going over some of the homework. So I have 2 points now. What else? How could I make this into 9? Because if I wrote log base 3 of 9, or better yet, what if I wrote 3 squared? I'd be able to figure that out, right? What could I make x be to make this into 9? So if we make it negative 7, what would this evaluate as? 2. I think I have enough to graph it. Let's see. I have positive 1 is 0. Negative 1 is 1. Negative 7, 1, 2, 3, 4, 5, 6, 7 is 2. And then the asymptote moved. It moved 2. It moved right here. X equals 2. If you solve this part, you would get x equals 2. That's how it shifted. So the asymptote comes from this argument part. And then your graph follows the asymptote and goes this way. See how this was x equals positive 1? That was the asymptote here. It comes from this argument. This, if you said 2 minus x equals 0 and solve that equation, you'd have, if you move x to the other side, you have 2 equals x. That's the asymptote. So it comes from the argument. Set argument equal to 0. Okay, so what else? We have 51 and 65. So this next problem is from the evaluate part. It's like, can you do math on logarithms? Not necessarily graph it, just do the math. So order of operations still applies. We have to do the inside stuff first. So the inside one says, what exponent will 27 have to be 3? Question mark. That's what a logarithm is saying. Logarithms are exponents. So I'm thinking to myself, 27 to what power would be 3? And in order for me to make it smaller, it needs to be a negative exponent. So this is what I do. I say 27 to what power, I don't know, equals 3, question mark. And I'm trying to solve for that exponent. What do we know about 27? How could you rewrite that as a base? Three to the third power. So if I rewrite this as, instead of 27, 3 to the third power, 3 to the 3x. Oh, I don't even need a negative. That was silly of me. I'm glad I'm solving this problem. Equals 3 to the first. What did we learn about exponential equations? We learned we could solve them if we had the same base. So now we can just disregard the 3's and say 3x equals 1, x equals 1/3. So we solved this. 27 to the 1/3 is 3. And that's true. The cube root of 27 is 3. So I'm going to replace this with 1/3. So the answer is going to be -1 because, are we on 51? Yeah. Because now we have to do it again. So we did this part and we got 1/3. The rest of it is, can you now make the base of 3 into 1/3? What exponent do you give 3 to make it 1/3? Logarithms are exponents. So the exponent, if it was 3 to the -1, that would be 1/3. So the simplification for this is the exponent, the answer is -1. So logarithms are all about exponents. What exponent would do this? What exponent would do that? What exponent? So that was 51. Then we have 65. That's probably one of those really long ones. Ooh, fancy. So let's try 65 and see what we know about rules. This says log base A of A to log base B of X equals 0. Oh, can't see it. So, I briefly showed you some simple ones like this. I showed you, let me show you some simple things again. If I said log base 3 of 3 to the 4th, what is that? We talked about them being inverses. What is it? It's 4. So if it's a base of 3 and a base of 3, they cancel out. We get 4. So what do you notice about this problem? This has a base of A and an exponential of a base of A. That means we can take this out and these cancel each other. We can just say that log base B of X equals 0. It's a little bit counterintuitive, but when we get to the point where we believe that exponentials and logarithms undo each other, then this is like taking the square root of a square. They undo each other, and whatever's left was what was in the inside, okay? So now I want a hamburger helper this. What's the base? Base on the bottom. No, the one on the, so base means bottom, so B. So when I hamburger helpered it, I circled it, and then I went here because it's the exponent equals X. Tell me what B to the 0 is. It's 1. X equals 1. So we want to remember that logarithms are exponents. And the reason that they were designed that way is so that we could say log base, we'll do the same thing they did. Log base A of A to anything, we could say A to the pi. That's going to be equal to pi because these cancel. If we said A to the log base A of 37, that's going to be 37. Because this is an exponential with a as a base, and this is a logarithm with a as a base, and exponentials undo logarithms, and vice versa. So as long as you have the same base, these cancel out and you get 37. So we need logarithms so that if we have an equation we're trying to solve, we can undo it. It's like if we had x squared and we know we have to take the square root, that's how we undo the square. So exponentials undo logarithms, and logarithms undo exponentials. So that's how, for some of these where you're solving, you go and you solve. So I think along those lines, and then I guess y'all did okay with the matching because no one asked me about those. Let's see.